All right, good morning. Last note sheet that we have here over 7G. If we have a trinomial written, usually we think of trinomials as ax squared plus bx plus c. We may see a trinomial that kind of looks like this, ax to the fourth plus bx squared plus c. If it's something like that where we have an x to the fourth, an x squared, and a c, we can factor it the same way. But instead of x's, we replace it with x squared. Once we get it factored down, we can factor it further. All right. And that's with our, our difference of squares, our difference of cubes, sum of cubes, anything like that. Primarily, we're going to be looking at that. All right. To find the roots, we set each factor equal to 0. So looking at this first example, x to the fourth minus 10x squared plus 24. We can do it like a trinomial like we always do. We have a 1x to the fourth, 24, so 24, our b term is negative 10. All right. Now we're looking for two numbers that multiply to 24 that add to negative 10. If you want to go to the calculator and do 24 over x, control T it to get your table, go for it. And we should arrive at negative 6, negative 4. All right. Which means we split up the middle term. So we have x to the fourth minus 6x squared minus 4x squared plus 24, and we'll GCF it. So x to the fourth and x squared, we can pull an x squared out of this, and we get x squared minus 6. Then, we have negative 4, negative 24, we pull negative 4 out. Get an x squared minus 6 there. Putting it back together, what we get is we get an x squared minus 6 and x squared minus 4. Okay? So, in terms of factoring it further, all right, we can factor the x squared minus 4 because this is a difference of squares. All right? So the x squared minus 4 can become x plus 2 times x minus 2. And we still have the x squared minus 6 over here. Okay? So setting each factor equal to 0, we know if x plus 2 equals 0, we have a factor at, or a root at negative 2. If we set x minus 2 equal to 0, we have a factor at positive 2. All right. If we set the x squared minus 6 equal to 0, all right, we plus 6 and plus 6. We get x squared is equal to 6. All right, we root it. And remember, if we root something, we have to take the positive or negative. So our last roots is going to be positive or negative the square root of 6. Okay, so we end up with 3 roots. We have, or really 4 roots, negative 2, 2, positive or negative 6, positive or negative square root of 6. All right. Go ahead and pause the video if you need to. Do 2 more examples here, and then we'll be done. All right. If the parentheses equal to 0 and we end up with a negative square root, the answer will include an I. If you remember imaginary numbers, it will have an I if we have a negative square root. All right. So if we try to go hammer this one out, okay, we have negative 36, 1 times negative 36 and negative 5. If you were to control T that, you get negative 9, positive 4. Those two numbers multiply to negative 36 and add to negative 5. So we'll split the middle. X to the fourth minus 9x squared plus 4x squared minus 36. All right. GCF it, so we have x squared and then x squared minus 9. And then 4 can come out of that. We get x squared minus 9. All right. Putting this back together, we have x squared minus 9. X squared plus 4. All right. Again, the x squared minus 9 is a difference of squares. So we can change that using our difference of squares rule, so x plus 3, x minus 3. Okay. So for our roots, x plus 3 equals 0, so we have x equals negative 3. X minus 3 equals 0, so x equals positive 3. Okay. Now with the x squared plus 4, okay? That's not a factor thing right there. We don't have any sum of squares, so we have to solve for x. So for the x squared plus 4, we said x squared plus 4 equal to 0. Minus 4 minus 4. So now we have x squared equals negative 4. Okay. The next thing we do algebraically, obviously, is we square root both sides. Okay. When we square root, we have to take the positive or negative. Okay. Negative 4. So the square root of 4 is 2. And the negative is going to give us an I. All right. So our other two roots are going to be plus or minus 2i. All right. So we have a root at negative 3, a root at positive 3, and we have our last two roots at plus or minus 2i. Pause the video if you need to. Last example. X to the fourth minus 28x squared minus 288. So we have 1 times negative 288. We have negative 288 and 28 down here. All right. And so our two terms should be negative 36 and positive 8. All right. Split the middle, so x to the fourth minus 36x squared plus 8x squared minus 288. All right. Factor this out, so we have x squared and then x minus 9. Sorry, x minus 36, I'm sorry. X squared minus 36. Over here we can factor out an 8. We get x squared minus 36. So putting this thing back together, we have an x squared minus 36 is an x squared plus 8. Okay. X squared minus 36 becomes x plus 6 times x minus 6. Again, this is a difference of squares. Okay. And again, we set each factor equal to 0 to find the root. So this one, the root would be negative 6. This one, the root would be 6. This one, okay, we have the x squared plus 8 equals 0. X squared equals negative 8. Root that and root that. All right. So, again, what we'd have to do here, the one on the test is not going to be this complicated, but we have the square root of 8. So we have to sort of break this down a little bit. So the square root of 8, negative 8 is negative 1 times 2 times 2 times 2 if you do the factor thing in the calculator. So what could come out? Well, 2 can come out, and from the negative 1 an I can come out. So x is equal to 2i, positive or negative 2i, I should say. Positive or negative 2i. So let's color code this here. So the 2's can come out as a 2. The negative 1 can come out as an I. And a root 2 is left. Okay? So our last root is going to be positive or negative 2i root 2. that's that. That's 7G. Going to be one of those problems on the test. I want to make sure that we are prepared. There's a few more example problems on the back y'all can try. Take care. Have a good day.